Excellent. So you should be seeing my desktop now. Um, and you should be seeing a slide that's got item number 10 from the test that we just did. So let me grab my annotation tool so I can do the magic that I want to do with these items. I forgot to pull in the the scores that you guys had, but let me just grab them in my notes here. On test number 2, so we had 22% A's, 31% B's, 22% C's, 11% D's, and 14% F's. Excuse me. As I talked about before, I usually look at A's and B's minus D's and F's. Well, A's and B's was 53%, and D's and F's was only 25%. So that's a plus 28 in that regard. Your class average was a 77, which is a C plus, which is quite good as we move through part 2 of the course. So what I've got for you is 4 questions here from the test that cause the most headaches, not only for you guys, but for students in general in this course. These are the items that have caused headaches on test number 2. So let's take a look at these 4. This first one is really a question about the levels of processing theory that we discussed last week, right? This was the one where we had a target word at the top of the page and then a question about each word. That was about how deeply you process the information. And what we said was the deeper processing leads to better recall. So if you read through all of this, basically what you come down to is choice A, because the best recall is going to be for folks who've thought about whether the word is a synonym or an antonym of another word. So you're thinking about the meaning, whereas the worst recall is probably going to be for folks who were tasked with saying whether the word begins with the same letter as some other word. Okay, so deeper processing, synonyms and antonyms, more shallow processing for same letter. So the correct answer choice there was A. About 2/3 of you guys got this one right. Okay, about 60% or so. The most difficult item on the test is the next one I'm going to look at with you guys. About 25% of you got this one right. So advertisers use enjoyable music, cute babies, attractive models, and funny spokespeople to create positive advertisements. The music, babies, models, and spokespeople are best thought of as what? Anybody want to take a shot at that in the chat box? Are they CSs? Are they neutral stimuli? Are they positive reinforcers? Francisco thinks it's USs. He's right. Why is it USs? What's the deal with these things? What do they cause in terms of reactions? Well, usually some kind of a positive UR, right? Emotionally something that is, moving in a positive direction, right? Enjoyable music, cute babies, attractive models, funny spokespeople. What's going to get paired with them ultimately is going to be whatever the product is, right? It could be some kind of beer. It could be some kind of car. It could be some kind of software program, right? And we pair these things together with the things that we know people really have a positive reaction to. So in this case, again, the correct answer choice was D. Okay, any questions on that one? All right. What was next? This one, about taxis that get smaller as you go up to the top of the skyscraper. Right? We don't think that they're tiny mini taxis down there. We think they're regular size taxis, but the retinal image has just gotten smaller and smaller. That's size what? Constancy, relativity, adaptation, or disparity. This was in the recording, right? This was a perception. This is size constancy. I thought that would be a relatively easy item, and maybe it caused some problems for people maybe who didn't even watch the perception recording that you guys were going to watch. All right, final one that caused headaches was this one. Excuse me, gosh. How does olfaction differ from the other sensory systems? This was something actually I mentioned way back in the bio section when we're talking about parts of the brain, and it was right. Matthew and Francisco are both on it, right? Olfactory inputs do not get routed through the thalamus. Remember I said repeatedly, everything other than smell goes through the thalamus as the sensory relay center again for everything other than smell. So the correct answer there was D. Okay? Any questions about that item or any other item that you've been obsessing about since Tuesday? Any feedback on the test? Too easy, too hard, just right, fair, unfair? What do you guys think? Okay. Olfaction potentially could have a significant influence on memory. That's not the reason why it doesn't go through the thalamus. I actually don't have a real good, simple explanation for why it has evolved in such a way as to be different. If I dug around a little bit, I'm sure I could find it, but I don't know off the top of my head. All right, let me kill out of this guy and jump over into our slides for today, where we are going to begin part 3 of the course by talking about intelligence and intelligence assessment. This is the point where I like to tell you guys we're moving into what I call the sprint part of the course. Why is it a sprint? Because if you look at the schedule and the syllabus, what we've got is 5 class sessions during which we're going to cover 4 chapters. Okay, so today we do intelligence. Next week, face-to-face, and then online we cover development. Then we have spring break. Thank God, right? After we come back from spring break, what we do is emotion, stress, and health, face-to-face. On Thursday, the 6th of April, we do personality online. And then we have test number 3 on Tuesday, the 11th of April. So 4 chapters worth of content, 5 days worth of class. And in fact, those classes, 3 of them are online. So today, next Thursday, and then the Thursday after spring break. The only face-to-face ones are the Tuesday before spring break and the Tuesday after spring break. So the speed with which I go through things is going to pick up. The good news is once we get through this sprint portion of the course, when we get to the final part, it'll, I think, sort of return to a more reasonable pace. It's not going to be so fast that you're going to get lost, okay? But you will notice that things do pick up a little bit, and probably they should, right? We're now moving into the second half of the course, and you guys have a good foundation under you in terms of what we've done in parts 1 and 2 of the course, and now as we move into 3 and 4, we can kind of continue at a pretty brisk pace. The organization I want to give you here, the outline I want to give you for intelligence and intelligence assessment is down below here. So we're going to talk at the beginning about psychological assessment in general, okay? Whether you're looking at measuring personality or different kinds of behavioral traits or something else, we can sort of do a macro level look at psychological assessment and try to define it, try to distinguish between it and other forms of assessments that you might do. Then we're going to zoom in and at a more micro level, we're going to talk about intelligence testing. We're really going to dig through the history of intelligence testing. We're going to look at contemporary approaches to intelligence testing. We're going to look at some sample items and subtests on these IQ tests that we use today. And then in the final 20 to 25 minutes, we will take a look at the nature versus nurture issue as it maps onto intelligence. And in the second half of the course, this is a major theme. So we're going to talk about nature versus nurture today as we talk about intelligence. Excuse me. Next Thursday, when we talk about language development, we're going to talk about nature versus nurture. After spring break, when we talk about personality, we'll talk about nature versus nurture. In part 4 of the course, when we talk about psychological disorders, we'll be discussing nature versus nurture as it maps onto those psychological disorders. So it's a pretty major theme here in the second half of the course for sure. Okay? So that's where we're headed. Let's begin with a look at what we mean by psychological assessment. Again, sort of at a macro level, what is psychological assessment and how might it differ from other forms of assessment that we might do maybe in a relatively informal way on an everyday basis? Well, psychological assessment, if we were to define it, involves using specified procedures to evaluate things. What are we evaluating? Well, we're evaluating people's abilities. We're looking at their behaviors. We're looking at their personal qualities. When we talk about abilities, we might be talking about something like intelligence, right? Or maybe we're looking at somebody's mathematical skills or their memory abilities. Those would all be different forms of abilities that we could examine via psychological assessment. If you're looking at people's personal qualities, well, in this part of the course, we'll talk about personality and personality assessment. And we'll look at, the quality of those approaches, right? If you're looking at psychological assessment of behaviors, this could involve behavior checklists that teachers or parents might fill out regarding children that are in their class or their own children at home, okay? I think the key phrase that I want to highlight for you in this definition up above is the phrase specified procedures, okay? I'm willing to bet that a lot of you, especially if you're taking psychology, because maybe you're a potential major in psychology, are curious about other people. And probably on an everyday basis, as you make your way through your day, you're doing informal, everyday kind of mini assessments, if you will, of other people. You're judging people. You're evaluating them. She's really, really smart, or that guy's really, really shy. I wonder why he's doing what he's doing over there. And then you try to figure it out, right? You're doing these little mini assessments. That's fine, but those are informal. What we're going to talk about is today a more formal approach to assessing psychological functioning with a focus obviously on intelligence, right? So specified procedures means it's not just like, here's, kind of the impression I got of her was this, or here's what I think of that guy. No, these are going to be rigorous, and I would even argue to some degree, relatively rigid approaches to assessing these different aspects of people's function. Again, today with a focus on intelligence. One of the things we're going to talk about on the next slide is how we have to use uniform testing procedures, right? Specified procedures where there's a manual that will literally spell out for you how you do whatever it is that you're doing in your intelligence testing, okay? So this is the story in general about psychological assessment. And the take-home message is it's a more formal, a little more rigorous, and even maybe to some degree rigid approach to assessing, again, abilities, behaviors, or personal qualities. What I want to do now is turn our attention more specifically to how we assess intelligence and look at some specific considerations that we need to keep in mind as we're going to do and look at different kinds of intelligence assessment approaches. So let me bounce to this next slide. And let me just mute myself for 1 second while I try not to cough all over you guys. I don't know where the cough came on. I was fine in the 8 o'clock section, but with you guys, I'm coughing all over the place. All right. So let's talk about important considerations in psychological assessment more generally, and obviously with respect to intelligence assessment more specifically. What's the story here? Well, we want whatever tools we're going to use to measure intelligence, for example, to have good reliability, to have good validity, and to follow the rules of standardization. With these 3 things in place, we can be pretty sure we've got a pretty good tool in our toolbox for measuring whatever it is that we're measuring. In this case today, we're talking about measuring intelligence. So here's the story. Number 1, reliability, right? The first consideration here. Oh, by the way, I guarantee you this is like 2 test questions right here. We talk about reliability, validity, and standardization. Reliability, as you guys learned about in the research method section, if we were to boil it down to one word, has to do with the consistency of a measure, right? So let's pretend for a minute that we are going to today develop the Lamecus IQ test. I want to get really rich from it. I want to be able to retire off of the money I'm going to make from the new Lamecus IQ test, and I want it to be great. Well, if it's going to be great, it's number 1, going to have to be reliable. Okay, it's going to have to yield consistent results. We talked about test-retest reliability back in the section on research methods, right? What this meant was our test, if it is reliable, is going to yield similar scores at time 1 and time 2. You guys remember this? We talked about this back in the method section. If we do a scatter plot of these scores, we should get a scatter plot that has a correlation coefficient of something that starts to approach 1.0, right? Generally speaking, people who do really well the first time do really well the second time. People who do poorly the first time tend to do poorly the second time. Okay, what we hope to get again is a line that goes through this, and maybe what we end up determining is that the new LeMake's IQ test has a test-retest reliability of positive 0.93. I'm just making up a number here. Okay, that's a really good, really strong correlation coefficient for test-retest reliability. Again, that means I give the new LeMake's IQ test today on March 16th. I give it again on April 16th, and the two scores correlate pretty strongly. And that's what we're seeing over here. Okay, is that enough? Can we just start selling it and I can get ready to retire on it? Is reliability enough? Tell me in the chat box. No, right? Back in that section on research methods, we had the reliable scale that said I weighed 100 pounds, and you guys kindly didn't laugh too hard about that. I used that to move into validity, right? We said validity in a word was truthfulness, right? This is truthfulness. Or I said it's how well does my measure say, how well does my measure what I say it measures, right? The extent to which a test measures what it's intended to measure. Right? This is where we run into some problems with online IQ tests, because many of them aren't broad enough to capture all the different facets of intelligence that we think are important, right? So this is, you know, an IQ test online where it's a bunch of math problems or it's a bunch of vocab. Well, that's not an IQ test. That's a math test, or that's a vocab test, right? If we're going to have a good, valid measure of IQ, like this LeMake's IQ test will be, or like the real Wechsler IQ tests are that we're going to look at today, it's going to need to be really, really broadly based, right? It's going to need to assess multiple facets of intelligence. It's going to need to include subtests on memory, on logical reasoning, on problem solving. Yeah, all arithmetic skills. Yeah, sure, on vocabulary. Something about speed of processing. And what we hope ultimately is that in one form of validity that we could talk about is that it's got some kind of predictive validity, that it tells us something about who may or may not be successful, maybe in a certain program or running a certain project or doing a certain kind of job, right? Predictive validity refers to the degree to which our test is good at predicting who will or will not be successful doing X, Y, or Z. Okay, so we've got reliability, it's consistency, we've got validity, it's truthfulness, and probably just as important for these formal, rigorous, and again, to some degree, rigid approaches to psychological assessment, we need to have standardization. What does standardization mean? It means using what we call uniform testing procedures. In English, that means treating everyone who takes this test in exactly the same way. Okay, so the Wechsler test that we're going to discuss today actually have a manual, and the manual tells you how you're supposed to sit with respect to the person that you're testing. It tells you, given their age, which vocab word to start with in that section, given their age, which arithmetic problem to start with. It tells you to do those vocab or arithmetic problems in this specific order. Again, rigorous and rigid are the two words that come to mind in thinking about these uniform testing procedures. Why these are so important is that I ultimately, when I'm done testing you, I'm going to compare your performance to the performance of your same age peers. What does that mean? That means you guys who are mostly 17, 18, 19 years old are going to have your performance compared to other 17, 18, and 19-year-olds. Your parents, who might be in their 40s or 50s, are going to have their scores compared to other people who are around their same age. Your grandmother, who's 75, is going to have her performance compared to other 75-year-olds. okay? If we follow these uniform testing procedures, then when we're done, I know that I can look at your individual performance and conclude something from that because you were tested in exactly the same way as maybe 8,000 other 18-year-olds were tested. And your grandmother was tested in exactly the same way that 10,000 other 75-year-olds were tested. Okay, it allows us to do an apples to apples comparison to your same age peers if and only if we use these uniform testing procedures. Again, rigorous and rigid is what comes to mind, right? We're doing this because we know on the back end, we want to be able to compare these two things to each other, right? The performance of this one person to everybody else who was tested in exactly the same way. Does that make sense? So these three things are necessary, whether we're talking about developing an intelligence test like we're talking about now, or later in part 3 of our course when we talk about personality assessment. One of the big sticking points and stumbling blocks, honestly, for some of the measures of personality is going to be around validity, okay? Is this test really measuring personality, or is it maybe measuring something else? Okay, that's what we've got going on here in terms of these considerations. Any questions about those three? Any of that not make sense? If the charted points were declining, so are you saying if we had, let me use a different color. Are you saying if we had something like this, we had like a negative correlation and it was going this way, that would be horrific for reliability, because basically what you're saying is that somebody who scored low at time 1 scored really high at time 2. That's not good, right? Especially if you're saying you're measuring a variable like intelligence, which is relatively consistent over time, okay? If you started finding that, I'd say you've got an unreliable IQ test, right? Or you've got a participant who's taking that test who maybe had something really dramatic happen between time 1 and time 2. Does that make sense? Good question. Thank you for that. All right. Let me ask you guys a question because I'm talking a lot and I keep coughing all over the place. So let me be quiet for a couple of minutes. And I did cue up the Jeopardy music because some of you guys were demanding that. The 8 o'clock section was demanding that. So let me give you guys a polling question. I want you to respond in the chat box. And I want you to give me an explanation for your answer if you would as well. Okay? So here's a question I've got for you. All right, what do we got? D, A. Sam is saying A because it is consistent. Matthew says A, the grades were consistent for both genders. Okay, Francisco is worried about it's not really a measure of learning. Okay, Anna's saying it's consistent but it's not valid or standardized, right? The correct answer is in fact A, right? It is reliable. What's the problem with it, however? Francisco's point is right on, right? It's not validly measuring, let's say, what you know about physics or algebra or history, whatever the course might be, right? It's not truthfully getting at, I like that, Cassandra, right? It's not truthfully getting at your understanding of that content. Instead, it's really, more than anything, it's a proxy for gender, right? I could look at the grade book and say, see all these grades that are C's? Those are all the guys in the class. See all the A's here? That's all the women in the class right there. Okay, so it is reliable, but it's not valid. Okay, so answer choice A is the one that actually is the correct one for that one. Questions or confusion about that at all? All right, good. Thanks for chiming in too, guys. It's really helpful when you not only give an answer, but you also explain it, because then I can get a sense of where the confusion might be as we're doing this stuff. Fantastic. All right, so what I want to do now is talk a little bit about the history of intelligence testing. Spend about 10, 15 minutes on that, and then turn our attention away from the history of it and look at what we do nowadays. So in contemporary intelligence testing, what are the approaches that we're taking? Alfred Binet is a name that you're going to encounter as you read about this stuff in the textbook. And he sought to develop a test in the early 1900s to distinguish between what today we would call developmentally disabled kids and quote-unquote normal children. The idea was, can we screen these kids and then offer appropriate programming to support kids who have some problems with learning or whatever the case might be, okay? Ultimately, he develops what is the first workable intelligence test in the early 1900s. In 1905, you can see some of the materials pictured down below here, okay? So, what was his approach? His approach, as you're going to read about in the textbook as well, was to take a broad-based approach to intelligence testing, right? Don't just give them a bunch of math problems. Don't just give them a bunch of fancy words. Do a broad-based test. And in fact, here's the cool thing about Binet's work. It was improved upon over time, and a lot of that work was actually done up at Stanford University by a guy named Louis Terman. And the Binet original IQ test ultimately became what's known as the Stanford Binet. So in contemporary IQ testing, the two big players are the Stanford Binet tests and these tests that we're going to look at called the Wechsler test. Okay. In his original work, it was the case that Binet used a concept called mental age in determining someone's intelligence quotient score. That's what IQ stands for. It's literally a quotient. We're going to be dividing something by something else and getting a quotient. So what was the mental age concept? Well, before I tell you what it is, I'm going to tell you we don't do it this way anymore. So this is a weird thing to do before you introduce the concept, say, and we don't do it this way anymore. But I want to tell you that on the front end so you don't get too obsessed with trying to figure out exactly how this works. Here's how it works. Mental age was an approach that Binet took that involved lining up, let's say, a series of 30 math problems. And as you work your way through those 30 math problems, we expect 10-year-olds to start to stumble at a certain point, and then 14-year-olds to start to stumble at another point, and 18-year-olds to start to stumble at another point, okay? And maybe 10-year-olds, just to keep it simple, usually get up to question number 10, okay? And then 14-year-olds, let's say, typically get up to question number 18. And then 18-year-olds typically get up to question number 25, okay? Well, if 18-year-olds typically get up to question number 25, and that's where you get to, no matter what your age, maybe you're 13, 14, 15 years old, but you actually get them all right up to number 25, and then you don't get any right after that, we'd say you have a mental age of 18 for that math subtest. Okay, so that's the idea. Mental age is this idea of having an increasingly difficult set of items where we know where people of certain ages start to fail to do those things correctly. Using that mental age concept, Binet developed a computation known as the intelligence quotient, or IQ. The quotient, again, was literally a quotient. It was a division problem. And what he did was he took your mental age and he divided it by your chronological age. And I'm just going to call that chron age here, okay? Mental age over chronological age. What's your chronological age? Whatever your age is. If you tell me you're 18, that's your chronological age. If I tell you I'm 46, that's my chronological age. If your grandmother tells you she's 75, that's her chronological age. So mental age over chronological age, that's a quotient because it's a division problem, right? We're going to take that and then we're going to get rid of the decimals by multiplying it by 100. So mental age over chronological age times 100. This is the formula down below here that was used to compute IQ scores originally. Again, we don't do it this way anymore. But I still want you to understand what this approach was and now why it didn't work particularly well. The problems here with mental age are really focused on the fact that there comes a point at which it's hard to come up with items that will distinguish between the abilities of people who are, say, 28-year-old versus, say, 25-year-old. Okay? It's probably best depicted in a little comic that I have for you here on the next slide, right? Check this one out. That's my boy Mark. He's 39, but he's already reading at a 42-year-old level. Now, that's funny because we don't really have a way of getting our heads around how does a 42-year-old reading level differ from that of a 39-year-old reading level, right? It's a 3-year difference. Well, 3-year differences matter if you're reading at an 8-year-old level when you're 5, right? 8 versus 5, I can get my head around that difference in mental age. But 42 versus 39, this highlights the problem with mental age. The problem with mental age basically boils down to once we get past about age 16, okay, it becomes increasingly difficult to come up with items that will distinguish, let's say, the performance of a 27-year-old from that of a 24-year-old, or a 27-year-old versus a 30-year-old. Whether you're talking about vocabulary, math, or whatever, you can't distinguish by age once you get past about age 16. So we don't take this approach anymore. What we do instead is we go back to what I mentioned before with standardized administration, right? With uniform testing procedures. And now we compare your performance to your same age peers. Okay? We move away from this mental age approach and we take an approach that permits us to look at comparisons between your performance and that of your same age peers. Okay? Let me stop there for a second. Any questions about Binet's approach, whether it's mental age or this computation, or why we now go to comparing you to same age peers instead of taking this mental age approach? Anybody need any further clarification on any of that? Okay, good. Looks like we're good because nobody's chiming in with anything on that. Excuse me. All right. Let's see if I can try to stump you with a little math problem here, because I like to give these on the test too, where I ask you to basically put this formula into action and do a little simple computation. And I don't let you use calculators if I were to give you one of these items on the test. So let me find that item for you. And then let me play the fun music that I know you guys just love so much. And tell me in the chat box how you came up with the answer you came up with. All right, 10 over 8 is 125, 1.25. 1.25 times 100 gets you that 125. Excellent. I'm glad nobody chose D and said, what? There's math in this class? Okay. You guys got it. Just plug the numbers in, do a quick computation, and you're good to go. Any questions on that one at all? All right. So we don't do it the Binet way anymore. What do we do now? Well, I've referred to the Stanford Binet test, which is sort of a further iteration of his original work. The other tests that are really widely used are the Wechsler tests. And these are the ones that I like to talk about, partly because I'm a little bit biased in that these are the ones I got trained on in graduate school. So did these with adults, did these with young kids down to like age 4 or 5. IQ testing with 4 or 5-year-olds is so fun. Let's talk about these tests. So the Wechsler Adult Intelligence Scale, or WAIS, is an assessment that is administered to people who are 16 or older. So if you were to go get some IQ testing done today, they might give you the WAIS. If you were younger, say age 10 or 12, they might give you the WISC, the Wechsler Intelligence Scale for Children. If you were really young, like I said, we did this down with like 4 and 5-year-olds when I was in grad school. There's something called the WIPSI, which is the Wechsler Preschool and Primary Scale of Intelligence. All three of them, the WIPSI, the WISC, and the WACE, have both verbal and performance subscales. And I'm going to show you some specific items in just a couple minutes here. Okay, verbal and performance. Verbal means, well, it's with words. Performance means it has to do with doing something. Ultimately, what we get from these tests is 3 sets of scores. A verbal IQ score, which is basically how you did on the verbal subtest. A performance IQ score, which is about how you did on those performance subtests. And a full scale IQ score, which is kind of the summary. This one here, the full scale IQ, when someone says, I have an IQ of 115, or I have an IQ of 95, or I have an IQ of 120, they're probably just telling you that full scale IQ score, okay? Instead of utilizing the mental age concept, which we saw sort of breaks down and fails once we get past age 16, IQ scores now instead are based on the normal curve, okay? This lets me again type in same age peers. Done that about 3 times today, and makes you remember the importance of standardization is what I'm trying to type there, right? Standardization means, again, I use uniform testing procedures so that when I'm done testing you as a 12-year-old with a WISC, I can compare your performance as a 12-year-old to that of other 12-year-olds, okay? Apples to apples comparison, because I gave you the same items, the same subtest, I did things in the same order, and so forth, okay? That's what I'm doing here when I'm doing that standardization, those uniform testing procedures. So ultimately, what I get is the normal curve, right? The normal curve is the bell-shaped curve that you guys are probably quite familiar with as you make your way through K through 12 education, right? The normal curve looks like this. Got it lined up for you on the next slide, so let me just go to that. Sorry about the coughing today, guys. Apologize for that. I can't get anything to click where I want it to click, so I'm just going to keep banging on. There it shows up. Fantastic. Here is our normal curve. On the baseline here, we've got the Wechsler Intelligence scores, right? We've got a mean of 100 and a standard deviation of 15. So let me type that in here for you. The mean is the average, and the standard deviation is just the average difference from the mean. Okay, so a mean of 100, a standard deviation of 15. Look down below. We can see it, right? Here's your average 100. Plus 1 standard deviation is 115. Minus 1 standard deviation is 85. Plus 2 standard deviations is 130. Minus 2 standard deviations is 70, okay? The normal curve is symmetrical, right? If we fold it on itself, it would line up. It's evenly balanced left and right. We also know on the normal curve that about 2/3, to be more specific, 68% of the population will score within 1 standard deviation of the mean, okay? Basically what we could say here is that 68% of the population will have scores that fall between 85 and 115. So I'll just type that in, right? So 85 to 115 is where these guys are going to be, in that middle 68%, okay? Almost everybody, 95% of the population is going to fall between 70 and 130, right? If you wanted me to guess today what your IQ score is, and I wanted to be very conservative and make sure I almost certainly captured your score, I'd say I'm pretty certain your score is between 70 and 130, because only about 5% of the population is outside of that range. About 2.5% would fall below 70, and about 2.5% would fall above 130. So if I wanted to be pretty conservative, I could say, you know what, almost certain here. Pretty much 95% certainty that your scores are going to fall between 70 and 130. Okay? If you wanted to get even a little bit fancier, I could tell you the percentile rank for a specific score. So let's say you have a score here of 115. So your cousin takes a test and she comes back and says, I got a 115. Well, you could say that score falls at the 84th percentile. And you would probably amaze her. And she'd be like, how do you know that? You'd be like, because I took Dr. Lemaica's class and it was awesome, right? How did you know that? Because 50% of the population falls below 100, and an additional 34% of the population falls between 100 and 115. So when you're at 115, you're at the 84th percentile, right? What does that mean? At the 84th percentile, you're scoring at or above the score of 84% of the population, okay? We had 100 people in the room. There'd be 15 or 16 other people who were smarter than you as measured by an intelligence test, okay? You'd be above average, certainly, in that context, okay, because you're at the 84th percentile. How do you calculate standard deviation? That's a great question. The good news is you're not going to have to do it. The short answer is you calculate it very carefully. No. You can actually calculate it by hand, but that would be like a punishment if I made you do that. Generally, what we do is we plug the numbers into statistical software like SPSS, or something called R, or we plug it into an Excel spreadsheet, and you can then calculate a standard deviation. It's basically the average difference of your scores from the mean. So if you were to become a psychology major, you're going to take a stats class and you're going to learn about standard deviations and how to calculate them. The good news is the software is there and it'll do it for you. Okay? All right, so remember, all of this is predicated. The normal curve stuff is predicated on what? What do I need to do? I need to do a standardized administration. So standardization is key. I want to be able to compare you to those same age peers. Okay, so we need that in place in order to be able to plot your score on this normal curve. Remember, standardization means treat everybody the same way. Same items in the same order. If it's a time section, I give you the same amount of time that I give someone else. I can't, give you less time because I think you're annoying, or give you more time because I think, you're a nice person, or you're really good looking, or whatever. No, everybody gets treated exactly the same way. You guys want to see some sample items? Curious to see what this looks like? Yeah, let's take a look. So here are some sample items from both the verbal and performance subsections of the WAIS. Let me just grab the verbal one here, put a little purple box around it. There are 6 subtests within the verbal subsection of the WAIS. General information all the way through digit span, and you can see what each of them involves, right? What day of the year is Independence Day? That's a general information question. Similarities. These are score 2, 1, or 0. Okay, so you respond to the question, in what way are wool and cotton alike? A 2-point answer might be they're both items that could be used, or they're materials that could be used to make clothing. A 1-point answer might be, well, wool and cotton are alike because they both have 2 O's in the word. Okay, a 0-point answer might be wool and cotton are alike because they're things in the world. That's really not anything, right? Arithmetic reasoning. If eggs cost 60 cents a dozen, what does 1 egg cost? So we do the math section verbally. It's kind of odd. You might think I'm going to give you a bunch of math problems to work on. No, I give you that. 2 points if you answer really quickly. 60 cents a dozen, 1 egg, so 60 divided by 12, a dozen means 12. 60 over 12 is 5. Okay? The more quickly you get it, the more points you get. If you get it right, but it takes you 30 or 40 seconds, you're going to get fewer points than with someone who gets it quickly. Vocabulary. What does corrupt mean? Comprehension, right? Sort of logical reasoning. Why do people buy fire insurance? Okay, well, to protect against a catastrophic loss in a fire. That would be a 2-point answer. Digit span is memory, isn't it? I'm going to read you a set of numbers, 7, 3, 4, 1, 8, 6, and have you read them back to me. About how many items do I expect you to get right on digit span? What's the capacity of short-term memory that we talked about last week? How many items can we hold in there? The magic number was 7 plus or minus 2. Yeah, Francisco's on it, right? Somewhere between 5 and 9. And this is where it gets fun. I was talking about working with the youngsters. I worked with 4 and 5-year-olds in grad school as part of the research project, and we did one little subsection of the WIPSI that included numbers, digit span backwards, where I read you 3, 8, 4, 1, 6, and you have to say back to me 61483. That's where it gets really fun. All right, performance. This has to involve doing something. So the first subtest here, we've got 5 of them to look at, is picture completion. Tell me what's missing in that calendar picture down below. Do you see what's missing? What do we need to have there that we don't have there? Yeah, the name of the month. Very good, Marissa, thanks. Picture arrangement. Put the pictures in order to tell a story. Okay, well, first he's going to run outside. He's going to roll the base of the snowman, put the snowman's head on top, and then give him a corncob pipe and a button nose. Fantastic. Block design, performance, do something, right? I give you 4 blocks that are red on one side, white on the other side, and half red and half white on the remaining 4 sides. Okay, the more quickly you assemble them in a pattern that looks like this that I give you, the more points you get. Object assembly, kind of like putting a puzzle together, right? Visual, spatial skills. Digit symbol. This is an interesting one in terms of age, right? Your 75-year-old grandmother gets compared to other 75-year-olds. She's given 2 minutes to do the subsection. She's not going to move through it as quickly as you will. Because it involves doing what? It involves putting the correct symbol above each number, and you have to work left to right. You cannot go through and put in all the 1s, and then go through and do all the 2s, and then do all the 3s, and then all the 4s, right? So standardized administration, left to right. And again, probably you will work through this more quickly in 120 seconds than your grandmother will. No problem. She's not getting compared to other 18-year-olds. She's getting compared to other 75-year-olds, okay? So that gives you a flavor for this. Look at the Wechsler test, right? Does it include everything that might be part of intelligence? Maybe not, but you certainly can't criticize it and say in terms of validity, it's not broad-based enough, right? It's not just a bunch of math problems. It's not just a bunch of vocab. It's not just a bunch of building blocks or puzzles. It includes all of those things, right? So I think it's, most reasonable people would say intelligence is hard to sort of quantify and nail down, but this does a pretty good job of getting us some kind of ballpark estimation of a person's level of intelligence. Okay? Any questions or comments on any of those subtests from the Wechsler test? All right, looks like we're good. All right. So in our last 25 minutes or so here, what I want to be able to do is walk you guys through a discussion about nature versus nurture. So this is the last thing on our to-do list, right? We've talked about psychological assessment generally. We've drilled down to some specifics about intelligence testing. We've looked at Binet's efforts, talked about problems with mental age. We looked at contemporary tests like the Wechsler test. We talked about the normal curve, looked at some of the specific subtests. The final segment here is going to be about the nature versus nurture issue. We first introduced nature and nurture back in week 1, right? So this was the third of the 3 great debates where we said, Greek philosophers developed 2 schools of thought about what makes people tick here, right? The nativists said, you are the way that you are because of genetic and biological sort of innate factors. And the empiricists said, no, it's not that. It's about your environment, right? So what your parents are like, how they treat you, what resources you have at your disposal, what your school is like, what your friends are like, those nurture environmental factors are what shape you. Well, the question up top here is going to be mapping this great debate onto intelligence in particular. So is intelligence determined by genes or environment, right? Is it A or B? Well, we'll get to the answer in just a bit. But before we get into that discussion, we've got to talk about a couple of terms, genotype and phenotype. And more importantly, especially because it's not only for this section, but it's also for our discussion about language development and personality and psychological disorders later, we need to discuss the logic of twin studies and adoption studies. So we'll get to those in a minute. Let's begin with genotype versus phenotype. So I need the bio people in the audience here to help me distinguish between these two. So if you were an AP Bio star in high school or you're taking bio here at SDSU, let's begin with genotype. What is the genotype? When we talk about genes and environment here, one of the terms that's important is genotype. So the genotype is what? Maybe we don't have any biology heroes in our online session right now. The genotype is your actual genetic makeup, right? So when you learn this, right, it's a genetic info collected from your parents. Okay, so the genetic makeup, right? So this would be something like for eye color, if you have blue eyes, we know that you are little b, right? Two recessive genes give rise to the blue eye color, right? And phenotype, as Anna says, is the actual presentation of the trait, right? So if I were to say that slightly differently, I would say the phenotype is the observable, right, characteristic. Characteristic. That's a tough one to spell when you're trying to speak at the same time, right? So we could actually sort of, you know, finesse this and say your WAIS score is a gauge of your phenotypic intelligence, right? It's your quote unquote observable intelligence made observable by your responses to the questions that are part of that test, okay? So genotype versus phenotype. So the observable characteristic for eye color here for little b would be blue eyes, right? For intelligence, it would be your score on the WAIS test. For personality, it might be your score on some kind of personality test, okay? So good, we've taken care of that. Now I want to talk a little bit with you guys about two major approaches to try to disentangle genetic and environmental contributions to IQ. Those two approaches are known as twin studies and adoption studies. So let's pull these apart a little bit. Twin studies are predicated on the fact that there are two different kinds of twins. There are monozygotic twins and there are dizygotic twins, MZ twins and DZ twins respectively. Monozygotic twins, what are they also known as? MZ twins are also known as what? Because the average person walking down the street is probably not saying monozygotic or MZ twins. They're probably saying these are identical twins, right? So these guys are identical. That means they share 100% of their genes. Fraternal twins, in contrast, I'm sorry, I just said it. Dizygotic twins, in contrast, are known as fraternal twins, and they share 50% of their genes, okay? So MZ means identical, share all the genes. DZ means fraternal, share 50% of the genes. All right, let me give you guys permission to be mad scientists for a minute. And I want you to somehow use MZ twins who share all their genes to help us disentangle genetic and environmental influences on intelligence. If I gave you, let's say, 50 pairs of identical twins, what would you want to do with them to help you figure out nature versus nurture? Because if you think about it, because they're identical, they've got nature dialed up to 100%. They're exactly the same genetically. So what do you want to do with them? Put them in different environments. Anna's got a great idea, right? What I'm going to do is basically raise these folks as MZ twins who are being raised apart. I'm going to tell you this, that the correlation coefficient for MZ twins who are raised apart for their IQ scores is positive 0.75, okay? It's not important that you memorize the number. It's important that you understand the logic here of why this tells us what it tells us about genes and environment with respect to IQ. What does this tell us? It tells us that genes matter, okay? Because these are folks who share all of the genes, but because they're raised apart, they share none of the environment. And look how similar their IQ scores are. They're at a correlation of positive 0.75. What's the highest that number could be? That correlation coefficient. It can't get any bigger than what? Yeah, positive 1.0. So this is, if you wanted one data point, because you were tasked with arguing in a debate tournament that genes are significant contributors to intelligence, this is the number you could use. People who share all their genes yet are raised in completely different environments are still very, very similar in terms of their IQ scores. Okay, so that's the logic of twin studies. We're going to come back to more on twin studies in just a minute. Let me give you the logic of adoption studies here. This is actually, I think, even a little bit simpler. What we do with adoption studies is we take a baby, take a child, and we compare that child's IQ scores to the IQ scores of their biological mom and to their adoptive mom. Okay? Think about this for a second. Okay? Child and their bio mom and their adoptive mom. If they're more similar in terms of IQ scores to their biological mom, what would that suggest versus the adoptive mom? Well, if they're more similar, that would be nature driving it. Let me ask you this. If genes were telling the story completely for intelligence, that is, if genes were the sole driving force for intelligence, what would be the correlation between child and adoptive mom in terms of their IQ scores if it was all genetically driven? It would be 0. It's not 0. I'll give you the number here, and I'll give it to you again on a couple slides from now. That correlation between child and adoptive mom is positive 0.16. It is admittedly not a gigantic number, but it is still statistically significant. So again, this is child and adoptive mom. Let me just circle what I'm trying to do here, right? This connection here, and that's got to be something about environment or nurture, right? Because this mom, this adoptive mom, has no biological connection. Any connection between them in terms of IQ scores has got to be attributable to environmental factors because they don't share anything genetically. Okay, more on that in a bit. So that's the environmental piece. This MZ apart number, positive 0.5, is a genetic piece. Here's what I'm going to do. I've got 2 more slides that I want to get through today. The first slide is going to be 3 pieces of evidence that suggest that genes contribute to intelligence. The second slide is going to be 3 pieces of evidence that suggest that environment contributes to intelligence. So let's do the genetic slide first. Okay, let me clear what I've got here and jump to the slide on data from twin studies. And what I'm going to say here is data from twin studies suggesting a genetic contribution to intelligence. That's this first slide, okay? Suggesting a genetic contribution to intelligence. Cool. Let me give you 3 pieces of evidence that suggest a genetic contribution to intelligence. The first one is this one right here, and we've already talked about it. This is going to be MZ apart, correlation equals positive 0.75, okay? Identical twins reared apart have a correlation coefficient for their IQ scores of positive 0.75. So this is going to be piece of evidence number 1 that suggests a genetic contribution to IQ, okay? They share all of their genes. That's why they're identical. They share none of their environment. That's because they're reared apart, okay? So genes really matter. Now, if this was a thing in terms of intelligence that was entirely genetically driven, what would that correlation coefficient be there for MZ apart? If intelligence was entirely genetically driven, the correlation between MZ twins would be what? Positive 1.0. So it leaves some wiggle room for nature. I'm sorry, for nurture. And we're going to talk about nurture. We're going to talk about environmental in the next slide. But this slide is about data suggesting a genetic contribution to intelligence. So the first piece is MZ apart, correlation of positive 0.75. The second piece involves comparing bar number 1 with bar number 3. What are these 2 bars? Well, bar number 1 is identical twins reared together. So let's be clear. These guys share 100% of their genes. Okay. What was the deal with bar number 3 here? Well, these are fraternal twins reared together. What is their deal? They share 50% of their genes. Notice that these are identical twins being reared together and fraternal twins being reared together. So the nurture piece is identical, right? These guys are being reared together and these guys are being reared together. So any difference that we get in the correlations for IQ scores between identical together versus fraternal together has to be attributable to what? They both are in situations where they're being reared together. So any difference between this and this is attributable to what? Genes or environment? It's genes, right? So this correlation coefficient, again, you don't need to memorize the numbers, is about positive 0.86. This correlation coefficient over here is about positive 0.60. Here's what I always do with this. This decrease from 0.86 to 0.60 is the second piece of evidence that suggests a genetic contribution to intelligence. Why? Because the people in bar number 3 are less similar genetically than are the people in bar number 1. And that's what's driving this decrease in the similarity of their IQ scores, right? We go from 0.86 to 0.60. It's not environment because they're both in situations where they're being reared together. The only difference is 100% the same genetically, 50% the same genetically. So that drop is due to a genetic factor. It's got to be attributable to genes, not environment. Okay. The final take-home message here is, look, by the time we get over to the 5th bar, we've got a situation where we have unrelated individuals being reared together. They share 0% of their genes, right? Because they're unrelated. Well, as we move across here, people become less and less similar genetically, right? Isn't that true? Become less and less similar as we slide across the slide. What happens with the IQ score correlations as we move across the slide? They get smaller and smaller. So that general pattern will be the third and final piece here, suggestive of a genetic contribution to intelligence, right? As you become less and less similar genetically, and we move across the slide this way, what happens is you become less and less similar in terms of IQ score correlations. That's the third piece of evidence that suggests a genetic contribution to intelligence. Let me stop there for a second. Any questions about those 3 points there? Yeah, there is. We do have evidence for fraternal reared apart. What would you guess is the case there for that one, Francisco? You think it's going to be bigger or smaller than 0.60, positive 0.60, if we have fraternal reared apart? It's going to be smaller, right? Like MZ together versus MZ apart, it drops by about 0.10. I think that number goes from like 0.60 to like 0.46 or 0.48. I just don't have it on the slide, okay? But you've got the idea, right? It gets smaller, and Anna was there with you as well. Good. That's what you just asked, and how you guys answered your own question indicates you're getting the logic of these twin studies. Again, I'm not going to ask you a test question that says pick the right correlation coefficient number. That's not what this is about, right? I want you to understand MZ apart says genes matter. I want you to understand MZ together versus DZ together. If that number gets lower, that suggests the genes matter. And then this overall pattern, as you become less and less similar genetically, you become less and less similar in terms of IQ scores. That is the final suggestive piece of a genetic contribution. Okay, is it all genes? No. You know that most of these things that are interesting are both genes and environment. So let's talk about the environmental influences on intelligence with the next slide. So 3 pieces of evidence that would suggest an environmental contribution to intelligence, right? Keep this clear in your notes. Now we're talking about how does environment, how does nurture, how does the empiricism approach get borne out in this research about intelligence? Well, number 1, we've already mentioned the child and adopted mother correlation, right? They share nothing genetically. Any similarity at all between them in terms of IQ scores has got to be due to environmental factors. It's statistically significant. It's admittedly not a giant correlation coefficient. It's about positive 0.20. But because it's not zero, that shows that environment matters. Remember, because she gives that child nothing in terms of genes. Everything she provides is about environment. The second piece of evidence that's suggestive of an environmental contribution to intelligence is the finding that the longer you spend in an impoverished environment, the worse that is for your IQ score. There's a deleterious negative effect on your IQ the longer and longer you're in a not so good environment. So IQ score gets dragged down the longer you're in a place where the schools are terrible, you don't have any books or libraries, you have poor health care, you have poor nutrition, all these things. The longer you're in that environment, the more that drags things down. Okay? So an impoverished environment has a negative impact over time. If this was just genetically driven, it shouldn't be able to be pulled down. It is pulled down because environment matters too. The third and final piece of evidence for an environmental contribution to IQ is something known as the Flynn effect. We know that an enriched environment can increase IQ scores over time. The Flynn effect, to be concrete, is a gradual increase or creep up in IQ scores population-wide. That means overall. That doesn't mean you have a individual level increase in scores, but population-wide of 3 points every 10 years or so. Think about this for a second. A gradual increase in IQ scores, population-wide, of about 3 points every 10 years. James Flynn is the researcher who first identified this. And basically what it says is people are getting gradually more and more intelligent over time. Okay? So a score of 100 on a Wechsler test in the 1950s is not the same as a score of 100 now, okay? So why does this suggest an enriched environment can increase IQ? Well, because first of all, genes don't change in populations that quickly. So these kinds of changes can't be due to genetic factors alone because genes don't change that quickly in populations. The other thing is that over time, what we see here is a multitude of factors that might be positive in terms of your IQ score in the population wide. Okay, what do we mean? Well, access to education has improved over time. That would contribute to higher IQ scores, right? You guys are probably, if I asked you to identify other factors, you would say, oh, technology, right? Access to health care. General nutrition, right? Even something as simple as number of children in the family might be an environmental enrichment that was better for you for realizing your intellectual potential than it was for, say, your great-grandparents, right? How many siblings did your great-grandparents have? Tell me in the chat box. I'll tell you that my grandmother, for example, was one of 11 kids. And then I was one of 5. And I have 3 children of my own, right? Anybody have grandparents or great-grandparents? Matthew's got somebody with 13, 15, a lot, right? So in terms of realizing your intellectual potential, right, and pushing this IQ score up over time, if you have fewer kids, you could do, more things with them that would improve their intelligence scores, right, on an IQ test. You can read to them more. I usually joke, if you have 13 or 15 kids, like Matthew and Alberto are mentioning, you might start bedtime stories at like 4 o'clock in the afternoon in order to be able to get through everybody, right? So smaller family sizes might be another factor here. But it's probably, as much as anything, access to education, healthcare, and nutrition that makes this gradual creep up seem to be something that persists over time. So again, 3 pieces of evidence here that are suggestive of an environmental contribution to IQ. Any questions on those at all? Looks like we're good. All right. In my last 5 minutes, I just want to introduce something that I'm going to circle back to and go into more detail on with you guys when we get together on Tuesday. I just want to remind you that you do have to do the Launchpad Learning Curve quizzes for intelligence. It's a piece of Chapter 7. It's only about 15 pages of actual textbook reading because it's not the entire chapter on cognition. It's just on intelligence. Let me just set this up for Tuesday because I want to circle back to this and sort of wrap up intelligence when we get together face-to-face and then move into the section on development. So I am going to talk on Tuesday at the beginning about this model called the reaction range. And here's the deal, guys. I love this model because it is one that lets us simultaneously entertain both genes and environment as contributors to intelligence. And that's what the research shows, right? That both genes and environment contribute. So what does this model suggest? Basically, the model suggests this. Everybody's got about 20 to 30 point range of IQ scores. Look at it with Tom and Jack and Susan and Jerome and Kimberly, right? About 20 to 30 points of a range that is anchored by a genetic gift, in quotation marks, that you get from your parents, right? So Tom's parents gave him a genetic gift that made his score probably fall somewhere between about 65 and 85. Alice got a genetic gift where the range is maybe 120 to 145. So genes are the anchor. And then around that anchor, environment will permit you to either move up and score higher within that range, or if it's in a deprived environment, look what it's doing to Jack. It's pulling him down to the bottom of his range, right? Because he has a poor school, right? He has no books at home, doesn't have good access to health care, etc. Those are things environmentally that are dragging him down. So the reaction range, again, is a model that lets you think about both of these factors, genes and environment, simultaneously. So your genes stick you somewhere in a neighborhood, if you will, of IQ scores. And then within that neighborhood, you might end up on the higher end or the lower end of the range, depending on the quality of your environment, right? The enriched environment folks are all scoring at the upper end of their range. Unfortunately for them, the deprived environment folks are scoring at the bottom end of their reaction range. Okay, so I'm going to spell this out in more detail on Tuesday. Again, you don't need to memorize any of these numbers. It's the concept, right? And the concept is going to be a genetic anchor in some range of IQ scores around which you will either move up or down depending on the quality of your environment. Okay? Let me stop there. Any questions about that or really anything that we've done today? Anything on this section on intelligence and intelligence assessment? We've done a real good job getting through our to-do list here, right? We've talked about psychological assessment in general, did a real good job of looking at the history of intelligence testing and some contemporary IQ tests, and then the final 25 minutes or so here on nature versus nurture. All right, any questions on any of that? Thank you, Francisco, good. All right, well, let's wrap up for today. We will, at the beginning on Tuesday, I'll even give you the warning here. We're going to do 2 clicker questions early on in class on Tuesday about what we've talked about here on intelligence. So make sure you get there on time because remember, if you miss both of the first 2 questions because you're not there, then you're not going to get attendance points for that day, right? Because if you miss more than 1 question by not being there, then you forfeit those 5 points for attendance. I've had a number of people email me about that. That's the rule, right? So make sure you show up on time. If I happen to do early clicker questions like I will on Tuesday and you're not there, you're going to be losing not only the question points, but also the attendance points for that day. Okay? Any final comments, questions for me? Awesome. I'm going to stop the recording here, stop the share, and end the session. So I'll see you guys on Tuesday. Have a good weekend. Don't forget to do your learning curve quizzes on intelligence. All right? Bye, everybody.